Welcome back. Problem 11, section 7.5. Integral negative 3 e to the 2t 1 plus e to the 4t dt. So that is square of this, which tells me let u equals e to the 2t. When e is u to the 2t, we have du equals e to the 2t times 2 dt. Alright, that's the chain rule part of it. So 2 e to the 2t dt. So e to the 2t dt is nothing but du over 2. That's why I need to divide by 2. Negative 3 over 2 e to the 2t dt over 2 is du. 1 plus u squared. So this is straightforward tan inverse. So negative 3 halves arc tan of u, replace u by e to the 2t. So let's try. Negative 3 halves arc tan of e to the 2t. Don't forget constant of integration. Good. Next problem. Integral negative sine 7x sine squared x dx. We need to use integration by parts. So I'm keeping this the first factor. Integral of sine squared, use double angle formula to obtain x over 2 minus sine 2x over 4. Okay. Then plus 7 times integral, derivative of x is 1, so there's nothing. You're going to take integrand to be this. So 7x, x halves minus sine 2x by 4, and integral of this quantity is x squared by 4 plus cosine 2x over 8 plus constant of integration. The whole point is use integration by parts. Negative sine 7x x over 2 minus sine of 2x over 4 plus 7 multiply x squared over 4 plus cosine 2x over 8 plus constant of integration. Correct. Integral 8x arc sine x dx. So arc sine x, I'm calling it as u. Then x itself is sine u. You see that x becomes sine u. Which tells me what is dx? It is cosine u du. So 8x arc sine x dx. 8, that's sine u. Arc sine gets me a u. And dx gets me a cosine u. Sine u, cosine u, I can use double angle formula sine 2u over 2. So 8 over 2 is a 4, u sine 2u du. At this point, we can use integration by parts. That's u. Integral of sine 2u is negative cosine 2u over 2 plus. Its derivative is 1, so that goes away. Integral of sine 2u is cosine 2u over 2. Its integral is still to be done. That gets me sine 2u over 4 because of that too. Alright. Plus a constant of integration. Multiply the 4. Yes. Reduces here. Multiply the 4. The 4 itself goes away. Now replace cosine 2u by 1 minus 2 sine squared u. Sine 2u by 2 sine u cosine u. Why am I doing all this? Because x is sine u, you see. So u is arc sine x. Sine u is x. U is arc sine. What about all of this? Sine u, cosine u. So I should have cosine u itself is 1 minus sine squared. I should write sine squared here. That gets me x. Alright, so there is a small typo here. It should be sine squared. Cosine u is square root 1 minus sine squared. So basically the final answer is all of this. Negative 2 arc sine of x plus 4x squared arc sine of x plus 2x square root 1 minus x squared plus constant of integration. Okay, so what did we do here? We used substitution, and then here we used double angle formula for sine, and eventually we used integration by parts, and upon completion don't forget to resubmit back. Problem 14, so 13 is good. 14. Integral negative 1 x to the power 4 x to the 10 plus 16. That gives me an idea. You see, x to the 10 plus 16, x to the 4. Well, let's take u equals x to the 5. Then the derivative du, differential du, has an x to the 4 dx. Alright, moreover, what is x to the 10? It's x to the 5 squared, that is u squared. So x to the 4 dx is 1 over 5 du. That negative is here, and you have u squared plus 16. This is straightforward arctan. Negative 1 over 5, because of that 16, I need its square root. That's 1 over 4 here. Arctan u over 4. Don't forget to resubstitute, multiply these two guys, and you have negative 1 over 20 arctan x to the power 5 over 4 plus constant of integration. Last problem of the section. Integral negative 8 over x minus 2 x squared plus 4 dx. You know this is going to be integration by parts. Okay, linear and irreducible quadratic. So linear fetches me a over x minus 2, and this one gets me bx plus c over x squared plus 4. Multiply here to make it one fraction, a times x squared plus 4 plus bx plus c times x minus 2. When you unravel it, combine like terms, you get a plus b minus 2b plus c and 4a minus 2c equals negative 8. So x squared coefficient is 0, x coefficient is 0, and constant term is negative 8. So you have these relations. B is negative a, c is 2b, therefore it's negative 2a, and lastly substitute c equals negative 2a, 4a plus 4a is 8a, a is 1, a is negative 1, b is 1, c is 2. When you plug it in, this gives me natural log. This is x plus 2, so I need to split it, x over x squared plus 4, 2 over x squared plus 4, right? So this gives me arctan. This is substitution, u and du, you see? So that gives me natural log. So that's your final answer. Negative natural log absolute value x minus 2 plus 1 over 2 natural log x to the power 2 plus 4 plus arctan x over 2 plus constant of integration. Okay, so that completes my problem list, section 7.5. Next video will continue with our next lesson. Until then, bye.